Okay, welcome back for the second part of this discussion on chi-square. As you recall, I had to break it sort of in the middle of an explanation on the previous video, and I apologize for that. I did back it up a little bit so that you'll have that information, or at least a little bit of a review there. I didn't back it up a whole lot, just 10 or 15 seconds. But let me just go back and review where we are on that problem. We've gone through and classified. This is a typical kind of a chi-square table that we might have. We've gone through and classified this, male and female, different types of shoes or footwear they might wear. The values that were in here, in these tables, in these spots here, okay, we're going to call those, they are the observed values. And then we go through and we, based on those observed values, we calculate these values here. Okay, and those are, since they're in the margin, we're going to call them the marginal. Okay. Finally spelled that right. Sorry about that. Now, if we add up this column total and the row total here, we should get that value here. These should both be the same value, whatever that value is. And then we take this value here, let's just call this one A and this one B, and this one C, D, E, F, G, and H. And for this particular observed, or for the expected value for this cell, expected value for that cell is going to be A times G over H. Okay, this value times this value over this one. If you think about that, then A over H is going to be some sort of proportion, some sort of ratio. You'd expect A over G to be in this cell and A over H to be in this cell and B over H to be in this cell. If you multiply it by G to get what actual value of that is. So you can think about it that way. So we left it at this problem at that position where we had the observed values, the expected values, and the next step is going to be to go through and calculate the observed minus the expected squared over the expected value. And if we do that for each of these cells, then that gives us the chi-square for that particular problem. So we'll go back and pick up this problem at that point. And that the chi-square is going to be the observed minus the expected squared over the expected. So the observed was 9. The expected value is what we calculated over here is 12.5. So we square that, divide by 12.5, and we get a chi-square value for that cell of 0.980. We do that for each one of those cells. It's a 2 by 4 table, so we do that for each one of the 8 cells. And then we add all those up, and that gives us our chi-square value that we look up in our table. All right? So, I don't want to do that for all of those, so let's go through and do another one, another example. So we're going to do a 2 by 2 table with 56 and 7, 5, and 34. And that gives me this table right here. I just put some labels on here. 56, 7, 5, and 34. These add up to 63. These add up to 39. Calculate my marginals first. 7 and 34 is 41. 56 and 5 is 61. So I've got those. Now, the next thing that I do, after I calculate the marginals, is I calculate the expected value. Okay? So the expected value is going to be this marginal times this marginal divided by the total. So 63 times 61 divided by 102. 63 times 41 divided by 102. I calculate that for each one of those. I get 37.7 and 25.3. And then for this one, it's going to be 23.3. And it's going to be 15.7. Now, notice that when I do that, this looks a little bit better here. When I do that, the 37.7 and the 23.3, that adds up to 61. So I can do another check on my data. 37.7 plus 25.3, that adds up to 63. So you can see that it does check out, that when you do these calculations, you still get the same marginals. So at this point, we have both the observed and the expected values. So we go in and we calculate the chi-square for each cell. 56 minus 37.7 squared over 37 gives me 8.88. This calculation gives me 13.24. This calculation gives me 14.37. This one gives me 31.33. To get my chi-square value, I add all those up. Okay? And I get that that's equal to 57.82. Next thing we do is we look that up in our table. First of all, we've got to get the degrees of freedom. For the degrees of freedom, this is the rows minus 1 times the columns minus 1. So for a 2 by 2, this is going to be 2 minus 1 times 2 minus 1. It's going to be 1 times 1. For a 2 by 2, it's going to give us 1 degree of freedom. For a 2 by 2 chi-square, or a contingency table, whatever you want to call it, it's going to have 1 degree of freedom. Okay? So we go to the chart and we look that up. Here's 1 degree of freedom. We go all the way over to the right on that top row, and this value here, you may not be able to see that. Okay? All the way over is 7.879. So our value of 57.82 that we calculated is certainly much, much, much larger than that. So this data is significant. There's a significant relationship. And I think that you can see that. Okay, I'm going to stop it at that point, and we'll pick back up with the next one. There at the end, it did get a little bit fuzzy, didn't it? I hope you didn't think that was your eyes that were messing up. That was the video. So we'll be back in just a